All right, this is section 3.1, and you'll want to pull your notes and follow along. It's a very relatively easy section, and there's some things that you may not know unless we go over it, but a lot of things are pretty straightforward. Let's take a look. Number one, what does it mean if a statistic is resistant? This is just a straight up definition. So if you take a look at your notes, it means that, look at your notes, statistic is not sensitive to extreme values. Let's look for something like that, and we'll talk more about that as we go along. So option A for me, extreme values relative to the data do not affect its values substantially. So if a statistic by definition is not sensitive to extreme values, then this answer is pretty darn close to that. That means that an extreme value does not affect it. If it is sensitive, then an extreme value will affect it. So this should be the right answer. Okay? All right, number two. The U.S. Department of Housing and Urban Development, abbreviated HUD or acronym HUD, uses the median to report the average price of a home in the United States. Why do you think the HUD uses the median? Well, we're going to talk more about this, and I will bring you back to this concept, but for now, the main thing to know is that housing prices are generally skewed to the right. So, housing prices are generally skewed to the right, okay? So, skewed right. So when they're skewed to the right, anytime you have a skewed set of data, that means that what? Well, let me do this. If the x-axis is the price of a home and the y-axis is the quantity or number of homes available, so as you go up this, the price of the home is increasing, right? So this is a home that's, let's just call it $50,000. And then this is a home that's, say, $500 million. Are there going to be a lot of homes in the $500 million range? Certainly not, right? But there are going to be more homes that are closer to the $50,000 range. Like, say, for example, in Texas, there are a lot of homes in the $250,000 range. So, naturally, your data is going to be skewed to the right because there are more homes in the lower price point because there are fewer people that can afford this, right? There are a lot of people that could afford a $500 million home, then it would be bumped up here, okay? But just due to basic economics, supply demand, socioeconomics, all those things, and just job market, right? We have more people in this range that can afford these types of homes. You're going to see this number, this quantity of homes being higher. So that's what they're kind of talking about here. Now, by definition, if you look at your notes, medians are better used, the median number rather than mean. Median is better for data that is skewed. So if you look at my options here, my graph of housing prices and quantity, it's not bimodal, it's certainly not symmetric, it's not skewed left, it's skewed right. So because it's skewed right, because it's skewed, you'd want to use the median, okay? I'll talk more about this as we go along, okay? Next, a histogram of a set of data indicates that the distribution of the data is skewed right. Well, we happen to have a graph that's skewed right for you already drawn there, or a picture of something. Which measure of central tendency will likely be larger, the mean or the median, and why? Now, if you look at your notes, for median, there's a area right below it or in it that says the median is better used for skewed data because extreme values tend to pull the mean up. Remember that median means the middle number. Mean is the average of it all. So if we have a bunch of houses all over and each of them have various prices, the mean is going to change by the highest end prices. It's going to average them higher. But the median, the price in the exact middle, so if I have 100 houses, the middle home, 50, 49, 50, 51, right around there, it's going to stay the same no matter what. So if you have skewed data, the mean is going to be pulled higher. The median is going to stay the same in general. So the mean will likely be larger because extreme values in the left tail. No, right tail. So because they said my data is skewed to the right, that means that I've got this picture. And so therefore, the right side, these big numbers over here, are going to move and pull the mean higher. Now, if they said the data was skewed left, you would use this one, the left tail. Make sense? Okay, so keep that in mind. All right, next, number 4. True or false? A data set will always have exactly one mode. So we're back to some definitions. And so if you look at your notes there, I can't remember if I wrote it into the notes, but the bottom line is that you can have more than one mode. Mode is the most frequently occurring element or data item. So a data set will not always have exactly one mode. Let me give you an example of that. If we look at our problem here with the housing, we could have 10 houses that are 250,000 in our data set. We could have 5 houses that are 50,000, one house that is 500 million. If they say there's only one mode, then that means that there's only one house that occurs, there's 10 homes that occur 250,000. But we could potentially have 10 homes that are also at 50,000. So if I say 10 homes, it's not the best picture, but say I have 10 at 240, 10 at 250, then I have a tie for the number of times we have a most frequently occurring element. 10 250s and 10 240s. We see them happen 10 times each. There's a tie for the most frequently occurring housing price. Okay, we'll see more of that as we go along. So if that didn't make sense for you, bottom line is that you know that a data set can have more than one mode. And you know what, while I'm on here, I might as well just point this out. Let's give you a sample data set. 1, 2, 5, 5, 2, 6, 4. What's the mode? The most frequently occurring element. Well, I've got 2 5s, but I also have what? 2 2s. So I've got a tie for the most frequently occurring element. I've got 2 2s and 2 5s. Well, if we answer true to this, then I can't have that. But clearly, I can have more than one mode. Okay, so anyways, that was a long explanation for that, but you'll get it as we go along. All right, so let's go and answer our first calculation. You'll probably want to pull a calculator here. Of course, my calculator is filming right now. So if you will help me with this, that would be great. I could also pull this up on Excel and we will do some Excel work here. But for this one, I'm not even going to mess with it. So find the population mean or the sample mean. Now the first thing you need to know in your notes that the mean can be for a population or for a sample. So recall that the population is everybody here. The sample is for a small subset, or not even small, but a subset of the population. Okay, you guys with me so far? Now, for the purpose of language and being able to differentiate between the two, I could find the average out of the population, average. I could find the average out of a sample. But if we use the same symbol, we might confuse the population average and the sample average. So that we can more easily differentiate between the two, we use this symbol to represent the mean of the population, and this symbol to represent the mean of the sample. Okay, so you gotta pay attention to that. So that's why this would be for the sample, this would be for the population. So sample, population. Now, what did they ask us to do? Sample, sample. So should I even check this one? No. That is an immediate elimination of that as an option because they told us that this is for a sample. That means we're going to first and foremost know that it applies to A, or A applies to it. Does that make sense, everybody? Okay. So make sure you differentiate between the two. Once you know that, you're still going to calculate it the same way. How do we find the average? Add these all up and divide by 5. You got it. Can somebody do that for me, please? For mom? Is it 11? Good. Okay, so I added all these up and I divided by 5 and I got 11. If you put 11 here, it would be the mean, but you would be claiming that it was the mean of the population. But you need to make sure you know the difference between the two. Everybody got that? Okay. Any questions about that at all? Okay. So there it is. All right. Let's go to the next one. This one's actually really easy. It says, for a large sporting event, the broadcaster sold 58 ad slots for a total revenue of $143 million. What was the mean price per ad slot? So all you got to do is take my price and divide it by the number of ad slots. Can somebody tell me what 143 divided by 58 is? Because they say round to 1 decimal place. Somebody tell me what that is?
2.465.
2.465. Now we need to round to 1 decimal place, so that's going to be 2.5. Everybody see that? So the average price per slot. So if all 58 slots cost 143 million, if I simply divide 143 million by 58, I'll easily find that each of those slots is an average of 2.5 million. Thank you. Good? We all right? Ready to move on? Fantastic. All right, now median. So we learned how to do mean. Now we're going to go do median. We know that median represents middle, right? Now, whenever you do median, there's one thing that always is important. You must order the values smallest to largest. It's the one calculation that requires you to sort your values smallest to largest. If they're not sorted, as an example, 51, 9, 27, 41, 12, and, well, let me do this. Screwed that one up. 41, blank, 27, 12. Let's do it that way, right? If they're not sorted, if I want to figure out the median represents the middle number. Now, this is how many items are in this list? 2, 3, 4, 5, 6 items, right? When you have an even number of items, you're not going to have one that sits exactly in the middle. So what it's going to be is it's going to be the average of the middle two. You guys follow me? You probably have done this before. If there was an odd number, meaning that let's say the 12 was not here, then it would be the 41 or whatever's in the exact middle. Now look what happens when my data set is not ordered versus ordered. Won't I have a different median by using the different middle two numbers? Or the different middle numbers? Absolutely. So the first thing that you need to make sure when you're doing median, so whenever you're doing median, is always make sure you're sorted least to greatest. Okay? Make sure you're sorted least to greatest. If you're not, If it's not looking something like this, you need to first sort them, all right? So let's take a look here. They say that the median is this. So they say that the median equals 32.5. Now we know that it's sorted, so we're good. This is an even set of numbers. So therefore, the average, this plus whatever this is divided by 2 should equal that. One more time. Because it's an even set of numbers, 1, 2, 3, unknown 4, 5, 6, then the median is going to be the average of the middle two so long as it's sorted, least to greatest. Arranged, least to greatest. So I know that 27 plus my unknown divided by 2, or the average of those two numbers, is going to be 32.5. You guys with me so far? All right. So how do I solve that equation? Well, I'll just multiply both sides by 2, right? So 27 plus x equals 65. How did I get 65? Because I doubled that, right? I multiplied both sides by 2. Maybe I need to write that out for you. You guys follow? Okay. Then what do I need to do to solve for my unknown value? Subtract 27, and so my value is 38. So this number right here, in my sequence of numbers, or my list or set of numbers, would be 38. Okay, go make sure you get yours correct. I'll double check my work. Are there any people that have questions about theirs? You guys okay? Okay, great. Let's move on. Okay, let's take a look at this next one. So, an insurance company crashed 4 cars of the same model at 5 miles per hour. The cost of the repair for each of the 4 crashes were $421, $447, $452, and $246. Compute the mean, median, and mode cost of repair. All right, let's do this together, shall we? I'm not going to pull up Excel. This is a small enough data set. Let's do it by hand, okay? In a moment, we're going to get to a bigger data set, and we'll do that in a big data set. For now, this is easy. All right, let's do the mean first. So the mean for this, for my problem, would be what? 421, 447, 452, 246. Add them all up, divide by 4, right? Can somebody do that one for me? We know how to do it. I just want to get through these. Do mine real quick. That way we can see that it's done properly.
It's 1,381.5.
Okay, then divide by 4.
Yeah, that's what I did.
Should be 391.5. Okay. Maybe you divide by 4. How did I know that your answer was a little bit off? Because if it's the average, then that means that the average has to lie somewhere between 246 and 421. The average can never be higher than your data values, right? Because the average is taking your data values and, well, averaging, dividing them, finding a number that kind of falls somewhere in between them. So hopefully this is correct. Oh, check answer. All right, great, thank you. Now, median. Let's do the median together, shall we? So the median of this, what do I need to do first? Order them, right? 246. What's next? 421, 447, and 452. So those are my 4 costs of repair costs. What did I do first? I ordered them least to greatest, didn't I? Is there an exact middle number when I have a set of 4 of them? No. If there was only 3, that would be the median. The 421 would be the median if there were just 3, right? But there's 4, so I'm going to need to average these 2. I'm going to need to add those 2 together and divide by 2. Somebody got it for me? Somebody got a median for me on mine? Should be 400 something. Yeah, 434. Thank you, that looks good. All right, so there's the median on that one. Now let's talk about the mode. What is the definition of mode? Mode is the most frequently occurring element. So if I have an element that occurs more than any of the others, that's going to be my mode. The problem with mine is that these all four of these are unique, aren't they? They're all unique elements. And when they're unique, and I don't have one that stands out that occurs more than any of the others, then that's when you would select there is no mode. You guys follow me? Any questions about that? We okay? Great. Okay, let's move forward. All right, now we need to go use Excel to help us out, okay? So I'm going to erase all this, I'm going to split the screen, and we're going to use Excel to help us do these kind of final problems. All right, so what I recommend you do is, you see this box right here, these double boxes, click them, open the data set in Excel. So I'm going to open my data set, okay? Okay, so here's my data set. Okay, you guys ready? So, I've got a concrete mix that's designed to withstand 3,000 pounds per square inch of pressure. Now, here's my data set downloaded. It's the same numbers that you see here. Compute the mean strength of the concrete. Now, I've already shown you how to do it by hand with a calculator, right? So I'm going to save us time now. There's no point in us doing this all by hand if we can do it on Excel, right? If I asked you to find the mean of this, you could. You'd add all these numbers up and you divide by the number of numbers. I don't know how many there are, 9, 10, 4, 5, 9. So in Excel, to find the mean, hit the equal sign, type average, average. Okay, and then select the first one that you want to average, and hold down the shift key and select the last one in the list. You guys follow me? So what do we want to average? We want to average the first value all the way to the last value. You guys with me? Okay, any questions about that? So let me show you that one more time. Average, first one, hold down the shift key all the way to the last one. And there's my average, done. What I'm gonna do is I'm gonna move this one down here so that I don't mistake that. Okay, so there it is. So the mean strength is 3,650. Got it? Any questions about that at all? All right. Now, median. So I'm going to, everybody ready to do median? Watch this. Don't do anything on yours, just watch. If I select the first cell, hold shift and click the last one, it's going to highlight all these. If I right click anywhere, it'll give me an option to sort them. And it will actually sort them for me, and I can do smallest to largest. Done. You guys see that? So it'll sort them for me, smallest to largest, and that'll help me select my median, won't it? So let's see here. Is there an exact middle? Yes, because there are only 9 elements, or because there are 9 elements in my data set, that gives me an exact middle value. Unlike the previous 2 problems, right, that had an even number of numbers, mine has an odd number of numbers, and so therefore I have 4 before and 4 after, there is my exact middle one. Now if there was an even number, then we average the middle two like we did in previous problems. So there we go. My median is at 3,820. Now I'm going to give you a little shortcut. Okay, ready for the shortcut? Shortcut, you don't even have to sort the data set. Equals, watch, median. And if I select the first cell and the last cell, whether it is sorted or not, it will automatically do it for you. You guys follow? But, of course, I wanted to teach you how to do it first. So, and there it is. Make sense? Do I have to sort the data set before using that command? No. I didn't have to sort it at all, but the reason why I sorted it is because I wanted to show you guys. Okay? So, mean, median, and that'll do it for you. Okay? All right. So now, last one, mode. Mode, you can eyeball it and just look at it. Is there an element that occurs more than any of the others in my data set? Which one is it? When it's sorted, it makes it really easy to see, doesn't it? The 4,080 occurs more than anything else. Okay, so I don't think you need to have a shortcut for that one, but you do, whatever. It's not too bad. Everybody got that? Makes sense? Questions? We okay? All right, let's go to the next problem, shall we? So, I'm going to close this one out. I'm sure we're going to pull another data set up. There it is. Okay, so here's the next problem. So our next problem, here's our data set. Let's take a look at it. I'm going to open it in Excel. Okay, and there we are. And let's go answer some questions, shall we? All right, so for number 10, it says determine the population mean pulse. So these are all the people in our population. How do we find the mean? Well, equals what? Average. Select the first cell, hold down shift, select the last cell, and there's our mean. Now pay attention, round on the rounding, round to the nearest tenth. So for mine, there it is. Okay? Questions about that at all? All right. Now, let's do the next one. They asked you for find the sample mean. So just quick note here, remember what we talked about, population versus sample? This represents the population. You guys with me? Now, what is this? Sample is that they took out some people out of here to form one sample and another sample. Do you guys follow? So the mean that we just found out here was that. And then these are going to end up being that. You guys follow? I'm just trying to make sure you start being able to see the difference. This is the population. We often think population has to be this big number of people or things. It's not necessarily. We can pull out some samples. Okay. So let's do the first sample. They want Kevin, Perpetual, and Crystal. So equals average, and watch how I do this one. So I still draw upon the average, and you guys can do this on a calculator. You don't have to do it on Excel. I just do it on Excel because one, it's easy to see. Two, you might use it later. Being able to use Excel is a valuable skill in general. And then three, my calculator camera is filming, so I don't have a calculator. So Kevin, I select Kevin. Then I hold down on my Mac, it's the command key. Yours probably is the control key. Is it control for other people? Okay. So then perpetual, there's perpetual, and then crystal. See what it did there? It allowed me to select individual cells to average. So if you're on a Mac, you're going to use the command key to do that. So you'll hold the command and select those individual ones, and then that's it. So round to the nearest tenth, so mine's 72.3. There it is. Let's go do the other sample. So the other sample is an average of, here we go, Tammy, select her, hold down, if you're on a Mac, the command key, if you're on a Windows-based computer, the control key, then it is Kathy, where's Kathy? There's Kathy, right under her, hold down, continue holding down the control or command key, and then Kevin, all three of these guys right here. There it is, and that's 72. All right, any questions about that at all? Great, let's keep on going. So now we're going to compare these sample 1, sample 2 to the population. So all three of these values are means. This is the population mean. These are my two sample means. You guys follow? So the mean for sample 1 is this mean lower, underestimating it, equal to, or overestimating it? Well, mine, yours might be different, is under that population mean. Do you guys see that? So for mine, I would say that the sample 1 mean underestimates the mean. Now, if your sample 1 mean happens to be over that or equal to it, you would answer it accordingly. You guys follow? Questions? Now, let's do the same thing for sample 2. So, does my sample 2 mean under, over, or right on the money equal to? Well, again, mine happens to underestimate the mean. Yours might be equal to, yours might be over. You're going to have to answer that question for yourself. You guys follow? Okay? All right, there you go. That's it for that one. Okay. On to the next problem. All right, so I've got a bar graph, a histogram here, and it looks like it's skewed, doesn't it? What side is it skewed to? It's skewed to the right. So we're skewed right. Now, that's an important observation because we're going to need it to answer the question. What measure of central tendency best describes the center of the distribution? Now, what did we say earlier in our notes? When a data set is skewed, what do we always want to use as the center? Not the mean, but the median. Now, if a data set is normally distributed or distributed, then we would use the mean as the center. You guys follow? But when it's not, when it's skewed like this, then you're going to use the median as the center, because the mean might fall over here because these outlier values are pulling that average up. When it's normally distributed or evenly distributed, then the mean is okay. Okay? All right? Okay. All right. So there it is. There's that one. Let's look at the next one. The following data represents the weights and grams of a simple random sample of candy. Okay, so I'm going to pull this data set up on Excel. So I've got a data set. Notice these are the same values over here. Determine the shape of the distribution of weights of the candies by drawing a frequency histogram and computing the mean and median. I recommend you do this with your data set, whether it's in Excel or by hand. I would sort your data smallest to largest. So I would immediately, right off the bat, sort your data smallest to largest. There's a reason for that. Why is it valuable to do that? Because when you sort your data smallest to largest, what does it help you do? It helps you easily build this frequency histogram, right? Because you know, for me, at least for mine, 0.81, 0.86, 0.87, 0.89, it shows me all my values. It will tell me how to build this, won't it? So let's take a look here. Let's look at my particular data set. My data set, it's saying that I've got one item that falls between, it looks like the way that it's split up, this is 0.79, this is 0.85, so right in between would be like 0.82. So this looks like this tick mark is for 0.79 to 0.82. Are you guys following me? Okay. So if that's true, if that one's true, I should only have one item in my data set that falls between 0.79 and 82. Is that the case here? It is. That one. Well, just from process of elimination, that means neither of these should be good, right? So you're going to need to figure out yours. Yours might be probably is different than mine, but based on what just my data set shows, it looks like that's correct in this. Okay? Did you guys get yours correct? Got it? Okay. All right. Let me know if I need to slow down. You just let me know. All right. Next. Okay. So the next question is the histogram for the data set skewed right, skewed left, or symmetric? Well, this is skewed right. Even though it's missing a little bit, it's still skewed right. This is skewed left, even though it's missing a little bit here. So this would be skewed left. You guys follow? Okay. So even if it misses a little bit, you're looking at the general shape, the overall general shape of it. It doesn't have to be a perfect skew right, skew left, even symmetric or uniform for it to be perfectly that categorized as that. All right, mean weight of the candies in grams. Well, I'm going to save myself a lot of time, and I'm going to use Excel to do this for me because I don't want to go do this all by hand. Round to the nearest thousand. You need to pay close attention. Always watch and read for what they're asking you to round to. Notice how previous problems, they said round to the nearest tenth. If you don't pay attention, you might put this as 0.9, be wrong. Pay attention to the rounding. Okay. Median. I'm going to save myself some time. Watch this one. Well, I guess it doesn't matter because it already sorted it, but I didn't have to sort it. I used the sorting feature to help me with my graph, but there's my median. Round to the nearest thousandth. Well, mine doesn't even go that far, so fine. You guys good? Hopefully you're ahead of me. If you got a question, let me know. What's the mode? Oh wait, no. That's not what they asked. I expected them to ask for mode, they didn't. Which measure of central tendency best describes the weight? When we are skewed, what do? Use the median. When we're skewed, we use the median. Okay? Alright, very good. Now, I am going to leave problem number 13 for you to do. Okay? So it's one problem for you to do on your own. It's very doable, you can do it. Okay? Number 14 is our last problem here. Okay? Let's take a look at this. Okay. Let me see. Make sure I'm on track. Yes. Okay. So in problem number 14, it's kind of a unique problem. It's not tough, but if you don't see it, it's going to be a little bit tricky. A professor has recorded exam grades for 20 students in his class, but one of the grades is no longer readable. If the mean score on the exam was 81 and the mean of 19 readable scores is 85, What is the value of the unreadable score? I'm going to help you guys go through this, okay? You ready? All right. This is like a 3-part problem, okay? I'm going to break it into 3 parts here to help you guys solve it. You ready? So part number 1, what I would do is take this information right here. So, let's see here. Oh, sorry. 20 students, there it is. So I've got one set of students plus another set of students, or my missing one, that when averaged is 20 total students. This part is a big batch of students. 19 scores, the batch of 19 scores. This right here is the one that I don't know. You guys with me so far? Okay. Now, when I add them together, whatever their scores are, because I know how to do averages, but I'm kind of in the dark here. When I add them together and average them, then they said that the mean score on the exam was 81. You guys with me so far? Okay. So that's the general framework. I have 19 students that I'm going to call as one giant value. 89, 95, 76, 54. All these different scores that add up to one big value. Okay. Then I got one that's no longer readable. Together, they make 20 total scores that when averaged will be 81 for the entire class. Got it? We're going to come back to this in a moment. All right. Let's take a look at 2. They give us some extra information. They said that the mean of the 19 readable scores. So these guys, the 19 scores, when I divide them by 19 to average them, the score, the average score is 85. Let's understand this one more time. Remember that this x represents the batch of 19 scores. It's all of them added together. If I average them, divide them by 19, the average of those 19 scores is 85. You with me so far? Okay. Let's go solve for x real quick. Let's go solve for x. To solve for x, I multiply everything by 19. Can somebody tell me what 85 times 19 is? I could do it off to the side, but it sure would be nice if somebody did it for me. And we got it?
1,615.
1615? Okay. Great. What does the 1615 stand for? It is all those 19 scores added up into one giant number. 95, 76, 44, 55, 62. Okay? Now what do you think we're going to do with that number? I'm going to stick this back into here. Because we know that 1615 plus my one missing score, if I average all that up, it's going to equal 81. You guys follow me? So what this did for us is this helped us know what the 19 scores totaled up to. And now my one extra one, be it a 75 or an 82 or a 93 or whatever it happened to be, when I add it to it and do the real average of all 20 scores, it's going to be 81. How do I solve this? Well, multiply everything by 20 over 1. Okay, so I get 1615 plus my one unknown score. Somebody want to do that? Is it 1620? No. No? Is it? Yeah. 1620. And then I subtract them. This looks pretty bad. Something's wrong. Something wrong here? Surely it's not a score of 5, is it? Really? They really throw out that bad of a score as an answer? Well, I'll be known. This person really messed up the average. Does that make sense, everybody? Okay, so there it is. So that one student didn't do so hot. Okay, so there it is. There's that section.